Yes, there is always a confusion. When it comes to work done by the force, yes, which force? Which force? Is it a constant force or a variable force? And if it is a constant force or if it is a variable force, how to find out work done? Let me just have that case where I have got a body of mass m and you're going to push it with a certain force. You're going to apply certain force on the body. Now what happens? Nothing actually. It starts from rest and the speed of the body increases and you say that there is acceleration. Yes, now what kind of acceleration? Is it a constant acceleration or is it a variable acceleration? This is the question. Now depending on whether the acceleration is constant or variable, I can have different types of force. One is the constant force, another one is variable force. What actually have got? Acceleration variable and I've got a variable force, and constant acceleration and I've got constant force. Now depending on these two cases we can have work done. That will be the next discussion. But my question is, when can you say that there is a constant force? Now you plot a graph. Let's just draw one graph. This is going to be force you are going to apply, and this x is the displacement of this body, right? It goes along x-axis. How fast it goes, yes, the acceleration decides, and I'm going to plot the graph now. Now 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. For every 1 meter, the amount of force you are applying, if it is the same, definitely I'm talking about a constant force. That means the plot of graph must be a straight line parallel to x-axis. Now if I draw the same graph for variable force, yes, along the x-axis you've got displacement, along y-axis you've got a force. Now again you got 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. For every 1 meter, the amount of force you're applying will not be same. It may not be same. Maybe in first 1 meter you're going to apply some 10 Newton of force. Then again you're going to getting tired, and again 5 Newton of force. Again you are so energetic, you're going to apply 50 Newton of force, and actually it's variable. That means this is a case of variable force. In such case, what is the work done? Now comes the confusion. Which formula I have to use? What is the formula to find out work done? I'm going to give you clarity here. Just don't worry. We have got a couple of problems. Let's find out how to find out work done in case of a constant force and variable force. That's what we are going to do today. Yes. Let's have first a case of a constant force. The left hand side is for constant force and right hand side is for variable force. I'll be giving you the direct formula, and how to use it definitely I'll be telling you later. Now for constant force, the work done is equal to dot product of force and displacement. And what we have to do is we have to take the scalar product of force, which is a vector, and displacement, which is also a vector. And displacement is actually the shortest distance between initial and final point. Now it's easy. This is going to be easy scalar multiplication. And in both the cases, in both the cases, F vector and R vector, they are actual vectors, and we should know how to take the dot product. In this case, definitely force is a constant. What about the another case? If it is a variable force, for example, the body is initially at the distance x1, it's the position x1, and it is going to the new position x2, and I want to know how much the work done. And every time the amount of force you're applying is actually varying, right? In such cases, we have to use the calculus method. It is just direct formula and integration of f with respect to dx, and you're integrating from initial position to the final position. Now all you have to do is you have to find out what is the force, this force, which is obviously not constant at all. It is a variable force, and we should know how to find out work done if they give force which is variable or a constant. And these are the two main formulas we are going to use, and we have got a couple of problems. Let us work out. Yes, the problem comes here. There is a uniform force of, MOD is given, and there is a particle of mass 2 kilogram, and it is displaced from initial position to the final position. This is initial position and this is the final position, and they are asking what is the work done. Now, is it a constant force case or a variable force case? Definitely it is a constant force. Why? Because this F, whatever I am talking, is not having any x. It's not changing with the x, because 3i cap plus j cap is a force vector which is not changing. They are actually constant numbers. Now, what about the position, initial to final? So, initial position, let me say R1 vector, because it's a vector representation. It's given by 2i cap plus k cap, and the final position vector is equal to 4i cap plus 3j cap minus k cap. All I need to find out is work done from initial to final, and it's a case of a constant force. So, which formula I have to use? The first one, F vector dot R vector. Let's use this formula. And what is R vector? Now, the problem comes when you don't know what is R vector. But R vector I can easily write as the displacement vector, which is the difference between final position vector and initial position vector. That means this vector minus this vector. Shall I do it directly? Why not? Let's do it. 4i cap minus 2i cap, that is 2i cap. This is 3j cap minus nothing, so it is plus 3j cap, and minus k cap, that is minus 2k cap. So this is going to be position vector. So let's take the dot product of the two vectors. F vector dot R vector? Yes, F vector is 3i cap plus 3j cap dot R vector I just got 2i cap plus 3j cap minus 2k cap. And this is direct a scalar product of two vectors, nothing else. Multiply the components, 3 into 2 plus 1 into 3 plus nothing, no k component here, so that means it's 0. So work done is equal to, so it is 3 into 2, that is 6 plus 3, that is 9 joule. So here the amount of work done for the case of constant force is 9 joule. Got one more question here. A particle come along x-axis, it moves along x-axis, and initial position x1 is given, that is 0, and x2 is also given 5, and they have given the force which is equal to 7 minus 2x plus 3x square, and they are asking what is the work done. Now question comes again, is it a constant force or a variable force? I think it is a variable force. You can ask me, sir, why? Why? Because this is the function of x. You see, when x changes, definitely when it is 0 meter, force is 7. When it is 1 meter, force is different. 2 meter, force is different. That means this is a case of variable force. That graph I have drawn. So which formula I have to use in case of variable force? Integration x1 to x2 f dx. And in this case, displacement is happening along x-axis and force is also acting along x-axis. So dot product of force and displacement is f into dx, cos 0 is 1. So this is equal to integration x1 is 0 to 5, x2 is 5, and f is given 7 minus 2x plus 3x square with respect to dx. The work done is equal to 7x minus 2x square by 2 plus 3x cube by 3. So I just have to put the limit, because we are finding out what is the work done from 0 to 5, right? So it is 7 into 5 minus 2 into 5 square by 2 plus x cube is 5 cube minus, put lower limit everywhere, that is 0. So work done is equal to 7 into 5, 35 minus 5 square, 25 plus 5 cube is 125, and this is equal to 10 plus 125, that is 135 joule. Now again we got how much the work done for a variable force, and we got again a same question but in terms of a graph. Now is this a question of variable force or a constant force? Now if you see the graph, F force is x, and you can see it's not a straight line always parallel to x-axis. After 3 meter you may see the force is actually decreasing, so it's a variable force. Now how do you use the integration concept, the direct formula that we used? But this is a graph question, so whenever you get the graph question, what you can do is you can use one amazing result, that is work done is given by area under fx graph. So this is the force versus x graph. Whatever you find out area under this curve, that will give you exactly how much is the work done. And how to find out? Just find out what is the work what is the area of this triangle, and sorry, what is the area of this rectangle, what is the area of this triangle, then you can find out what is the total work done. Now, how to find out area of this? Area of that is equal to this is actually 3 minus 0 into this is this 3 minus 0 again plus what about area of this triangle, half into this is 6 minus 3 into this height is again 3 minus 0. So it is 3 into 3 9 plus half into again is 3 into 3 9. So 9 plus 9 by 2 is 4.5. I think it's 30.5 joule. And do you have that? Yes, we have it here. So I have showed you how to find out work done in all the cases, whether it's a constant force, variable force, or when it comes to the graphical question, we can find out what is a work done by any type of force. Thank you, thank you, thank you.